Go.
I'm Ryan. This is my first year in FTC Robotics and Robotics in general, and I'm a designer and builder for Team Leo.
Hello, I am James. This is also my first year in FTC Robotics and Robotics in general, and my job is a designer and builder for Team Leo. Today we're going to be talking about our intake systems, or comparing them. My Arrowhead intake
And my rubber band intake.
Go. This is my Arrowhead intake. It is two 3D printed arrows that are connected to servos that will spread apart from the inside of the cone when inserted. Thank you. The way it works is that these two arrows go in the top of the cone and latch onto the lip on the inside. From there, it has incredible holding power and is very hard to shake it off. Take it. With these Arrowhead intakes, it could get us an estimated 50 points per game.
My rubber band intake utilizes rubber bands in order to bend to the shape of a cone. This increases grip and allows me to grab a cone from any height, whether it be the top or the bottom or the hem hook.
I don't even think it's legal in the game though. Like, actually no, you can grab it from the bottom, but it won't. You're not allowed to put it from the top down, right? Okay.
In combination with the fact that this is a claw-style intake, it allows the intake to maintain effectiveness whilst having little accuracy. You're not needing to rely upon high accuracy. With a number of numerous, some unmentioned, factors, it was able to achieve an estimated 100 points per game. Whilst I'm certain that was a good intake, James, and is able to effectively grab cones, there are a couple of flaws that I've noticed.
What?
It requires a lot of accuracy. It has very little space that it covers, and thus requires you to be precise.
But we do have a Lexan build on our robot that guides the cone into a little corner space that allows the intake to go in and grab it.
Just that in itself has a couple of flaws as well.
Like what?
What about those cones that are against the wall? The only way that you could get those is if your intake could reach them. Because whilst you could push them, I see no real feasible way that you would be able to push them off the wall. Additionally, what if one of these were to misalign themselves? This requires precise alignment, so then it would be ineffective.
But each servo is automatically coded to go to a certain position, so it would automatically reset itself. You see, there's two screws connecting to the servo, so it would never be misaligned unless it were to break.
And there's the final problem, James. This is 3D printed, and thus, it should be easily broken.
So, Ryan, while your intake is very effective at grabbing cones, as we've seen, at the same time, it is a very rudimentary and basic design. And while it doesn't seem to, while it's not exactly bad, at the same time, it's very limited at what it can do. You have to grab the cone, turn around, put it on the thing over and over and over again. While there can be so much more potential with your design, or with a design, in order to intake on one part and output on another side without having to turn around so fast. It's a good design, it's just very limited as to what it can do.
James, those are great points. However, we've installed this new 4-bar design onto our bot, which allows us to do exactly that. Intake and outtake from whichever side we need. This intake was specifically designed in order to be more compact. Maybe not the most compact, but it was designed to be compact whilst being effective. This way, it could effectively swing underneath our bot and then drop the cones.
At the same time, though, that would drop the cones upside down, which, as we mentioned it earlier in the video, that is against the rules of the game.
It is against the rules of the game, you're right. However, the 4-bar has that covered as well. The 4-bar has a wrist-style motion on it, which allows it to flip the cone. So, for example, if I were to intake, then it would be here, wrist rotates, then it goes down the correct way.
You know, we've done a lot of talking about the 4-bar. Let's show the 4-bar.
Let's.
So, like, that just happened.